Hi, my name is Guadanxi, 12 years old. For this lesson, we'll be continuing on for the techniques and applications for definite integration. For this lesson of definite integration, we have to determine the volume of the region bounded by z equals to 6 minus yx squared and the planes y equals to 2x, xy equals to 2 and x equals to 0 and the xy plane. So over here in this case, you tell from this part that this shape over here, it's definitely a curve from the x square. So over here for this part, it will have the x square curve and it will be moved a little bit and also will be somewhat widened and all. Okay, so yeah, over here for this part, that's somewhat what the shape is like. And if you look at the xy plane, basically if you look from below or above, how the shape will be here, what you will see over here, and what you'll see is and then over here we have y equals to 2x, whereas the shape is somewhat like this, okay? And then what will happen, so over here the y and x for this part, so x will, over here you have this part, right? So over here y equals to 2 and so apparently over here y is supposedly equals to 2. While for this part we have the x equals to 0. So the x equals to 0 will be.
It's 10:17 p.m.
Okay. And since this part we have the x equals to 0, what we're going to have here will be, so we have the, if we look at the 2D part, we don't need to look at the xy plane, okay? So we have the y equals to 2 and all these, right? So what we're going to have here is, so this that one, there's the z, that's when they stack up and all, okay? So over here and then the stack will be like a curve and all. Okay, alright, now that we have known what the volume bounded is like, how we can solve the question. So let's start. So we're going to have two methods over here, really just because one for dx and one for dy. So method 1, what we'll have here is, so the volume will be equals to, so technically over here for this part what we'll have is the triple integration v dv, right? And v dx dy and all, so yeah. Whoops, I accidentally wrote this. So it's the v dv basically. So over here what we're going to have here for this part, so for the j, the reason why we can do double integration over here is that the j, since this part basically stacked up straight up like this and no curves outside, so for this part it's basically the boundary will be from 0 to 6 minus 5 have x squared. So what we'll have here is 6 minus 5x squared dx dy. So accordingly over here, you can choose to integrate with respect to x first or respect to y first without any problems, right? Well, let's start with integrating with respect to y x first, which we are going to have. And so y equals to 2x, so x is going to be half y, and it will start from 0. So it will be from 0 to half y. Then after that, for our y, we have a 0 to 2. Okay, so what we'll have here is that, so now that we have gotten this part, we can already integrate it, which we are going to end up with a 6x minus 5 over 3x cubed 0 to y over 2 dx. And then we substitute it inside and we get, so for the first part we have 3, right? So we will have 3 minus, well, this will be over 8, 5 over, so 8 times, so there's 8 and then 8 times 3 over here, you have a 5 over 24. Okay, so this is what you're going to have over here. Okay. Whoops. This is a dy since we integrated with dx first. So here you're going to have this part, then we can integrate it once again, which we are going to get a 3 times 3 over 2 y squared minus 5 over 24 times 4 y to the power of 4, and then from 0 to 2. So over here for the first part, what we're going to have here, 2 squared is basically 4, and 3 over 2 becomes 6, and then this part, 2 to the power of 4 is 16, and 16 over here we will divide for this part, 3 times 8, you'll have you'll be left with 6 as the denominator and 5 as the numerator. Okay, so what we're going to have here, so what is 6 minus 5 over 6? It is equals to 31 over 6. And that is our result. Now, we already know that we can solve it with dx first, with respect to dx first, but what if we solve it according to dy first? That would be method 2, which we will have to integrate with respect to dy first. So for the first part, it will be pretty similar, but because that we are integrating with respect to dy first, our boundary would most definitely not be the same. So what we'll have when we integrate with respect to dy here, we'll be going from like this to this, so we'll be from basically 2x to 2. So here we have 2x to 2, and then for our x over here will be, since we've known that this x is equal to 1 when y is equal to 2, which is the boundary set, so over here it will be from 0 to 1. Now that we have gotten this part, we can straight away integrate for y, which will end up with 6y minus 5x squared y from 2x to 2 dx. And for this part, when you substitute it inside, what you're going to get, you're going to get 4 terms, whereas we'll have 12 minus 12x minus, over here you times 10x squared plus 10x cubed dx. And now you can integrate it once again, which you're going to get a 12x minus 12 over 2, which will become 6x squared minus, so over here you're going to have a 10 over 3 from the integration, and this part you're going to get a 10 over 4 for integration again. So for this part, now that you have integrated all of these, you can substitute the boundaries inside, where at 0 you're just going to end up with 0, so you can obviously ignore it. Well, for the 1, you're going to end up with 12 minus 6 minus 10 over 3 plus 10 over 4. Oh, whoops. So for this part, what we're going to have here is, so we'll have, so 12 minus 6 is obviously 6. Well, for this part, this is basically 10 over 3 plus 5 over 2. Whereas we can common denominator where we times 2 times 2 and then times 3 times 3. So what we're going to have in the end over here will be 6 minus 5 over 6 once again, and obviously we'll get 31 over 6. And that is all. So for this lesson, this is mainly it. So we have these two methods where the only difference is that one we integrated with respect to x first and the other we integrated with respect to y first. And then for this part, we just roughly explain the volume bounded. So that'll be all for this lesson. Last but not least, thank you for your watching.